You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.
Hello, this is Richard Jacobs with the Future Check and Finding Genius podcast. I have Wolfgang Smith. He's a scholar and researcher in the fields of mathematics and physics, but also a writer on theology, metaphysics, and religion. He's coming out with a movie, it looks like January 10th, The End of Quantum Reality, which we'll talk about a bit. And I want to talk to Wolfgang about many subjects. So, Wolfgang, thanks for coming. How are you doing?
Just fine, thank you. Glad to be on the program.
Oh, good. Well, tell me a little bit about your background and your what you've been studying over the long years.
Well, I started quite early. I was 14 when I became very interested in the question of physics, and of course very naive about it. But the idea that physics can explain all that happens in the universe, the fundamental science that fascinated me. So that was the start of it all. And so I entered Cornell University when I was 15, and I majored in physics, mathematics, and philosophy. And the time I graduated at 18, I had found that I couldn't agree with everything that I was being taught. So really, it all started way back those early days.
Well, now that it's going to be 2020, hasn't physics and science solved everything? And they know the universe now. Tell me, even after all this time, what do you see literally as of today? How close are we as scientists and physicists and, also humans thinking about the metaphysical realm? Are we anywhere close to figuring out the nature of reality?
Well, I think what has happened in physics over the past 100 years really is that we are entering a kind of reductio ad absurdum. Instead of getting closer to a solution, we seem to be getting further away, and fundamental questions loom up to which no one seems to have the answer. So it is a very strange period in the history of physics, and in a sense it is self-defeating. Questions arise which physicists can't answer, and so we are, as I see it, reaching the end of an era, a 400-year arc of history which began with Galileo and Newton seems now to be approaching. And
so what is, I guess what I'm seeing in general, and I'm just one person, but I speak to a lot of scientists and clinicians. I'm seeing a division where religion and metaphysics are ridiculed, and a lot of people seem to be, at least on the surface, comfortable with the idea that the universe came from nothing spontaneously, and random events and this mysterious thing called evolution drive everything. That's what I'm seeing. What have you seen over time, and what are you seeing now?
Well, I'm seeing that, first of all, let's talk about physics because it's a fundamental science. And what I see in physics are really two things, and they're quite different. There is the bona fide physics, and this is something known only to the physicists. So you do the equations, and you do the experiments, and you know how to predict, and then how to measure and test these predictions. And this is a marvelous thing, and in fact, it is something that has led to profound discoveries beginning of the 20th century, and it's a discovery of the quantum realm. It's a discovery that our Newtonian ideas were actually superficial and only approximate. So this is one thing, but at the same time, there has always from the start been an underlying philosophy. Actually, to be precise, it's the Cartesian philosophy of Rene Descartes, really, that has sort of entered into the bloodstream of physicists. They are generally unaware of the fact they have this philosophical predisposition, but that's part of what we by physics. So physics consists, therefore, of two things. There's the technical thing, the authentic physics, and there's the rest of it, the worldview. And this is what I call scientism, because it is something that pretends to be science and based upon science, but it is not science, nor is it validated science. And this is what the general public, of course, takes to be physics, the findings of physics. They don't do the mathematics and the experiment. It's all scientism in the broad public outlook. And
what is scientism then? What kind of definition? How would you define it?
Well, let me give you an example. We all believe in our normal hours, at least, in the sense-perceived world. We believe the grass is green, for example. Well, the physicist in his scientistic hat denies that. He says that the real world is quantum stuff, and qualitative attributes such as color are subjective or imaginary. They're in the neurons or in the mind or however you want to think of it, but they most assuredly are not in the objective real world, because that's the world that he studies and describes with his differential equation, measures with his empirical apparatus. So this is a prime example of what I call a scientistic belief. This belief that we do not actually perceive the world, that, for example, color is what Galileo, by the way, Galileo is the one who did this back in the early 17th century, and this is really the beginning of this new phase, so-called enlightenment Weltanschauung, which through Isaac Newton gained almost complete control of our Western civilization. So the idea that the grass is not green and that physics has proved it, that is a prime example of a scientistic belief, by which I mean it is supposedly based upon science, it is supposedly tested. That is actually false. It cannot be based upon empirical observations at all, and it is not, it has not been. And in fact, there are strong arguments, even empirical basis, for saying that this subjectivist theory of sense perception is actually false. So here's an example, and it is an important example because it enables us to recognize that if we were to take the findings of physics seriously, I mean scientific claims seriously, we would then deny what we in daily life firmly believe. So as I pointed out in my writings more than once, the scientific worldview we've been subject to for close to 400 years has really made us schizophrenics, in the sense that we, in our moments of enlightenment, we deny what all the rest of the time we firmly believe. So my writings have been very much devoted to this enterprise of sharply distinguishing between authentic scientific findings, the findings, for example, that power our amazing technology from jet airplanes to cell phones. This is all based upon the first component of physics, the authentic science, as distinguished from the rest of it, the scientific beliefs, which is what the public knows about physics. They don't know the Schrödinger wave equation and the rest of it. So what the public imbibes from this scientific culture in we find ourselves is really quite illusory, and I don't think it's beneficial at all in effect our civilization.
So what would be a more beneficial interpretation?
Well, I'm among those who believe that wisdom and enlightenment didn't just begin in the 17th century, that there are thousands of years of human history where there have been great men, philosophers, prophets, men of high attainment, and that we are absolutely, it is absolutely needful for us to pay heed to what they have to say and to learn from them, and to get rid of this contemporary notion that everybody in the world was somehow primitive and unlearned, basically ignorant, until Sir Isaac Newton came along to bring light into the world. This is more or less what we learn in our universities today, and I say it is not only false, absolutely unfounded, but also I think it is very harmful in its effect upon human development, on our civilization. We need some of the wisdom that bygone ages have to pass on to.
So any well, maybe it's silly to ask, but any concrete examples, any specific beliefs that you see are detrimental to to society or to people just in their daily lives? Any examples that really strike you?
Well, I think that at the core of it, there is the atheism that most people take away from so-called science. I'm very disturbed by the fact that our universities have been literally taken over by people who have completely succumbed to the scientistic outlook, so that the poor young people who go to the university to learn something and to gain wisdom of various kinds are actually subjected to a kind of brainwashing. So my own belief is this, that to the extent that anyone actually believes what the scientific worldview proclaims as having established is ipso facto insane. It is an insanity. The corollary here is that fortunately nobody believes it all the time. This is what I meant to illustrate with this idea of the question of the grass is green. In our normal daily life, the grass is green. And when we sit down and contemplate the world from a scientific point of view, then it isn't anymore. Then green is a kind of subjective, whatever it may turn out to be, but it is definitely not in the grass. It is definitely not a part of the real objective world, because, so the story goes, the real objective world is exactly what the physicist describes, differential equations. So,
well, they're not able to really describe the world, because it's, I guess, one of the strangest things to me, the most befuddling, is the Heisenberg uncertainty principle, which seems to put a limit on being able to quantify what reality is. It's just we try to get around it with tricky experiments, but it just seems to be a impenetrable roadblock.
Well, the Heisenberg uncertainty principle is absolutely true with reference to so-called quantum systems. But the important point is, and this is something that has been puzzling physicists for over a century now, the amazing thing is that you cannot really assume that the entire objective world is nothing but a quantum system. And incidentally, I'm glad you brought this Heisenberg uncertainty principle out, because it relates to a problem which has really stymied physicists for, as I say, roughly a century, called the measuring problem. Now, here's what happens. You measure a quantum, and at the very instant of measurement, the differential equation that describes a quantum system is interrupted. There's a discontinuity, and whereas, say, an electron, as described by the wave equation, wave function, multilocates, the instant you measure it, it no longer multilocates, it is at a precise place. And so with other quantities pertaining to the quantum realm, the moment you measure them, a discontinuity occurs, and the equations that normally describe quantum systems are interrupted. And the point is, no physicist has been able to explain that, to understand that. And so all kinds of, for the most part, very wild conjectures have been proposed by physicists in order to explain what happens measuring operation. And I won't go into some of these. I mean, to show how deep the question lies, some people have tried to approach this by assuming that at the moment you measure a quantum system, the world splits into as many other worlds as there are possible solutions, possible measurements. This is, of course, wild, and you might even say insane, but it illustrates how difficult this measuring problem is from a standpoint of physics. Now, this is really something that I got into many years ago. I happened to come across a book by a physicist named Nick Herbert entitled Quantum Reality. It's a book he published in 1985. And in this book, Nick Herbert says, best kept secret is that science has lost its grip, physics has lost its grip on reality. So this interested me very much, and so this is what got me into the philosophy of physics. I realized enormous fundamental problems concerning the nature of physics, how it relates to reality. And so I began to investigate. And as a result of investigation, I wrote a book in 1985 called The Quantum Enigma. And the very first chapter is entitled Rediscovering the Corporeal World. And what I tried to do with limited success in this chapter 1 is quite simply to argue and to convince reader that the world we perceive is actually real. The grass is green, the apple is red. You can hold it in your hand. You know it through our five senses. And so...
But what is this, like, I'm sure you've tried to take your own stab at understanding, let's say, quantum physics. What have you come up with? And, I'm just curious.
Well, this is what I'm trying to lead up to. I have not discovered any new physical laws. I've not done the work of a physicist. But in this book called The Quantum Enigma, I have done this. I have given a solution to this so-called measuring problem, which, so far as I know, is the only solution standing today. And as I said, the first chapter of this book, called Rediscovering the Corporeal World, was a matter of showing that the world that we perceive through our five senses is real. It's not in my head, it's outside. So, based upon this first chapter, all the rest of the book followed rather logically, because if what I claim to prove is right, we're left really with two different worlds, the corporeal world and the world of the physicist, which I call the physical world. So, and they're quite different. I mean, in one world the grass is green, and the other it's all quantum stuff. And so the basic problem then was, how do these two worlds fit together? Well, what I did, and I must say quite rigorously in this book, The Quantum Enigma, is this. I proved that you can do all of physics based upon its modus operandi, it's the way physics operate, by distinguishing two ontological planes, the corporeal world, which we perceive, live and being, and the physical world, the world as described by the equations of physics. And these are two ontologically different domains. And incidentally, this connects very closely with the ideas of Heisenberg, whom I regard to be the greatest physicist, deepest metaphysical understanding involved, because Heisenberg made a very fascinating observation. He said that when it comes to quantum particles, we're dealing with something that is midway between being and non-being. And he says that these particles thus are reminiscent of what Aristotle called potencies as compared to actual beings, which are said to be in act. So, in a sense, what I'm doing is just following along lines which were initiated by Heisenberg. So, I arrive at this idea of the two worlds, the corporeal world and beneath it, the physical world, which is a realm not of actual, but of potent. And so what I show with, I think, complete rigor is the fact that you can do the whole business of physics on this conceptual basis, which means also that there's no scientific way of disproving this claim of mine, this dichotomy between corporeal and physics, because, as I said, according to the modus operandi of physics itself, all of physics and whatever it may lead to empirically can be interpreted on that basis.
Quick question, is all life part of the corporeal world or just humans or?
Well, let me get to that in a moment. What I wanted to say to complete this particular arc, sort of a summary of what I do in this book, The Quantum Enigma, is this, that based upon this distinction of between the corporeal and the physical, based upon that distinction, you arrive at an automatic solution of the measuring. Because what happens in the act of measurement is quite simply a transition from the physical, the quantum world, into the corporeal. Because a measuring instrument has to be corporeal, failing which it would be imperceptible and therefore wouldn't measure anything. So this resolves the measuring problem in the sense that the discontinuity, the so-called collapse of the state vector, as the physicists call it, can now be understood in ontological terms. And now to get to the question you just raised, all that we perceive normally actually conceive as well belongs to the corporeal world. This is a world in which we really find ourselves. What the physicist has done is discovered a new realm, ontologically speaking, beneath the corporeal, a realm of potentiae, which incidentally the ancient metaphysicians knew that such a world exists. I don't think they had the remotest idea that you found an exact science dealing with structures in that world of potentiae, and that this would lead to an incredible technology. That, of course, it did not know. But the existence of a subcorporeal realm is something that has been very well known by the great.
Well, I hope this is not a offensive question, but I know you're older. Did you ever correspond directly with Werner Heisenberg, or are you even old enough to have corresponded with Einstein? Maybe forgive me if that's a stupid question, but it'd be really cool if you did with either of them.
No, I did not correspond with Heisenberg. I'm certainly old enough that it would have been possible. I met Albert Einstein when I was 11 years old, but that's another story. It was. Oh,
that's really cool. Actually, if you don't mind, it's just as a short diversion. Would you mind telling that story? That's really cool.
Well, my family had just arrived from Europe. We were in New York City. It was the summer of 1941. I was 11 years old at the time, and our friends, all of whom were from the old country, you see, we just arrived, they said, well, New York is very hot, you better go somewhere else. And so we vacationed in Lake Placid, New York. And the hotel we stayed in was full of people speaking German and other European languages. And so the owner of the hotel knew that Albert Einstein, who also wanted to get away from Princeton, New Jersey, he was also in Lake Placid. So he invited Professor Einstein to come and talk to us in German. And I remember it well. I was very impressed, especially because I had asked my mother not so long before that, who is the most intelligent man in the world? And of course she said, Albert Einstein. So I was very, very excited when I was 11 years old to be looking at the most intelligent man in the world.
That's really cool. Did you talk to him?
That's how it all came down. Yeah.
Oh, you listened to him lecture, but did you actually get to meet him and talk to him at all?
No. It was just, to be honest with you, I don't even remember exactly what he said. He was speaking to us for about half an hour in German, and I was fascinated, and I can still see him there. But if you ask me what did he say, I draw a blank.
Okay.
Nothing that had made any impression.
So back to your. Thanks for sharing the story, by the way. But back to your dichotomy. So, if we accept what you're saying, that they're the two worlds, the corporeal and the physical, how does that change science, for instance? How would that inform better science going forward?
Well, it changes science drastically. In the first place, let me just mention a technical thing. I've said that the act of measurement is a transition between two different ontological planes. Now, inasmuch as such a transition can only be instantaneous, therefore the causation that affects this transition cannot be the kind of causation that we deal with in physics. In physics, we deal with causation that is propagated through space. I call it horizontal causation. And the causation that actually gives rise to an act of measurement does not propagate through space. It is instantaneous, and I call this vertical. So the first thing that comes out of this resolution of the measuring problem is the discovery of another kind of causation, vertical causation, which does not take place in time. Now, once this idea has been formulated, you can then recognize that vertical causation does enter into physics itself in a number of ways. I won't go into it because it is technical, but physicists have long known a phenomenon termed non-locality. And this is something that cannot be explained on the basis of horizontal causation. Einstein was very disturbed about. Well, here you have another instance besides the act of measurement where vertical causality enters the picture decisively. Now, in 1998, a mathematician by the name of William Dembski proved a remarkable theorem. He proved that what he calls complex specified information is something that cannot be produced by natural causes. An example, if I write a book and I don't copy it, it's original, then I am producing complex specified information. And according to Dembski's theorem, natural causes, or what I call horizontal causes, cannot produce complex specified information. So it happens that all of us, all human beings at least, avail ourselves of vertical causation in our so-called free acts, our acts which are not in fact determined by some mechanical, I say mechanical, I mean on a molecular level, quantum mechanical basis. Well, this is very interesting. I mean, it actually begins to relate to the religious sphere because, as you know, I think every bona fide religion in the world insists that human is endowed with something called free will. If that were not the case, the whole idea of sin or good and evil would really collapse. So we have free will, and this is something that can now be understood on the basis of vertical causation. Vertical causation is active universally. I mean, throughout the universe, you find vertical causation at work. And this is something that, from the physicalist point of view, was denied. In other words, the physicist believes that physical causation is all there is. It explains everything. And whatever cannot be explained in terms of physical causation is superstitious, is a false. Well, that has now been disproved. Vertical causation is live and well, and incidentally, I am personally persuaded that it plays an absolutely foundational role in all biological phenomena. In my last book, I referred to physics, the science of the inorganic. In other words, as soon as you get into the organics, vertical causation plays a central role, and which means that physics is unable to explain the phenomenon of life. So biology will come into its own once it begins to recognize acts of vertical causation and understands the difference between vertical and horizontal causality.
Oh, so I guess a question coming in from the side here is it possible for people to create AI that will be, have the capabilities of a living being? Or do you think that because, AI is not corporeal or it can't cause this vertical causation? What's your thoughts there?
I'm very glad you raised that question because it's important. AI is something very illusory. First of all, it's misnamed. It's not artificial intelligence. It's artificial something else. You might call it reason, or it's a kind of a robotic intelligence. And the idea that it is that you can build a mechanism of any kind which is capable of intelligent act is entirely false. This is utterly impossible. So the acts that robots can do and do very well are acts of horizontal causation. They are not acts of vertical causation, which is really where intelligence begins to end. So the AI propaganda, I would say, is very misleading and very, very harmful, really, to humankind because it is suggestive of the idea that we are all complicated machines. Well, we are not. We are not machines at all. We are something entirely different. It is true that every living organism has within its corporeal nature all kinds of molecular mechanisms. These have been, of course, discovered now, the DNA and so, and this is all very fascinating. But the point is, the DNA alone does not give you life. And incidentally, I was talking with one of the finest biologists quite recently, and he told me that if you look at the fertilized egg of a fruit fly, let us say, when it begins to divide and form a living organism, in 24 hours, the complex specified information this organism multiplies by some enormous factor. In other words, the passage from a fertilized egg to a living organism consisting of billions of cells is something that cannot be reduced, cannot be explained in terms of horizontal. Vertical causality does end the process, and I think this will become known and proved in the biological world probably in a very short period of time. Within a decade or two, I think the leading biologists are just on the verge now of recognizing this basic. So the idea that living organisms are basically machines, so they may be molecular machines. This, although still believed in major quarters, the days of that belief are numbered.
Where do you think is the origin of life then?
Well, the origin of everything is in God. There's no question about that. And every civilization, every religion from the lowest to the highest has recognized. I think we are reaching a point now where this basic recognition will again be discovered, so to speak, and it will become the leading paradigm of human life once again. As I have mentioned before, I believe that this 400-year arc of history began with Galileo and Descartes and is now reaching its end. And so this will be a rediscovery of the vertical dimension, which is based upon God the Creator. I mean, the distinction between God and the universe defines, as it were, a vertical axis, the axis leading up to Creator, up to God. And this discovery of the vertical dimension is what is now drawing very near. A number of discoveries have been made which point in that direction. A number of people have expressed these ideas very, very clearly. And I think it is just a matter of time before this scientistic Goliath will actually disintegrate. He's still very
Okay.
powerful, and in fact, there's a tremendous ideological pressure driving our sciences. Anyone who thinks that there's freedom of the scientific world is sadly mistaken. The whole project is ideology-driven. It is a kind of religion. I like to think of it as an anti-religion. It is a religion from below, and it is very aggressive, and it is very intolerant. There's no freedom of speech. I could tell you a lot of stories, but I won't because we have better things to talk about. But science is not what it is supposed to free rational inquiry into the nature of things. There is an ideology behind it, and in fact, in the last century, this ideological factor and the pressures resulting from it have increased enormously, to the point where actual mendacity has occurred. In other words, there are results being falsifications that are being suppressed. All sorts of things are happening in the physical sciences, which really shouldn't surprise anyone. Billions of dollars are involved, and the upper echelon of the scientific periti, the scientific leadership, has enormous social standing. I mean, they are the accepted gurus of our society. And so it should not surprise anyone when I claim that actual mendacity has entered the picture here and there. And anything but a free society where everyone is able to express his views, it's a kind of dictatorship. And
science has become it's politicized. It's a political weapon, and it's become politicized. And you're right; things have been not told or told in certain ways that may not be what they really are. And it's difficult.
Yeah, you've mentioned the word I was groping for: politicized. That's exactly the right word. It has been politicized, and it is no longer possible to assume that every journal article has been properly vetted, that negative results have been reported, consequences drawn, etc. And this is only going to get worse because, as I say, I see the physical sciences in a sense reaching a crisis state. Now, in the case of particle physics, which is a foundational physics, what has happened is that in the last 50 years or more, the top-ranking physicists have been trying to put together, so to speak, the ultimate theory of physics, where all particles, everything making up quantum stuff has been duly discovered and put together in a wonderful, grand, unified theory of everything. And the result has been one failure after another. Incidentally, a very fine German physicist by the name of Sabine Hossenfelder has written a fantastic book called Lost in Math, where she is, so to speak, the whistleblower, if you will, documenting these failures one after another. Let me just give you one example. For a long time, something called superstring theory was regarded as the non plus ultra, the theory which will give us all the particles that make up reality. And these particles were characterized by a property known as supersymmetry. And so this large hadron collider near Geneva was built in large measure in order to detect the supersymmetry particles. So there you have a tunnel going under parts of Geneva, 16 miles, I believe, in circumference. I don't know how many billions of dollars it cost. And the fact of the matter is that all the supersymmetry particles that were supposed to be detected, not one of them turns out to be there. So it has been one of the great fiascos of physics, and most so-called string theorists are now drifting into other into other spheres.
Right.
These failures obviously are not publicized, but as I said, Sabine Hossenfelder has written a fantastic book, I think is the beginning of a recognition on the part of the larger world that physics, fundamental physics that is, has entered a state of crisis.
Wolfgang, we're just about out of time. The last thing I wanted to make sure we got in is just very briefly, what movie is coming out? Tell people the name and where they can find it.
The film is called The End of Quantum Reality, and we are just booking theaters in various parts of the country where it will come out beginning in January. We have Los Angeles, we have Boston, we have Pittsburgh, we have Cleveland, we have San Diego, and a number of other places, and we're still trying to increase the list so that we'll have at least 10 cities in the United States where the film will be shown. I guess they call that arts theater.
Okay, excellent. Well, Wolfgang, for people that want to start to take the journey that you've been describing, should they go to Amazon and get one of your books, or what's your recommendation on how they can go further with this conversation? Well,
we have a website, philos-sophia.org, Philos, Philos -Sophia, SOPHIA.org. So this is, on that website, you'll find lots of information. I write an article there about once a month. And then there's another website on Facebook. They call themselves the Wolfgangsters. Anyhow, I can't give you the coordinates. I'm not much of an internet expert, but it's an interesting website, and various people post opinions. There's a lively conversation going on.
Well, very good. Well, Wolfgang, thank you so much for coming. I really appreciate it. It's a unique opportunity to talk to you. Thank you.
Well, thank you for inviting me. It's a great honor. Thank you.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.